Cool. Looks like we're live. The non-standard book list for software developers. Alright. Teaching the slow process of becoming everything you hate. The sunny side of firing someone. Let's see. Better cook spaghetti using a ruler and a fundamental principle of physics. The formal theory of spaghetti code. How to design better APIs. That could be a good one. Francis Fukuyama. And okay. Let's take a look. Let's take a look at what they got going today in Hacker News. Single sign-on sucks. I could take a look at that. All right, let's take a look. A view of software development as a big logical system with highly interconnected complex parts. Yes. Understand such a big system requires having an excellent grasp on the tools used to build them and logic itself. Correct. What follows from that are starting parts, element parts, which are decomposed into more complex ones, which spot complete nonsense in the system, and how to decompose the complex parts back to more fundamental ones and check the consistency and truth. Correct. Okay, makes sense. I can honestly say that it's the most life approach systems, be it math, even politics, that pay close attention to the definitions taken around me. The logic is all over the place. I draw conclusions from one set of assumptions, but a false one from another one's. Okay, interesting. A book about geometry on the surface. Aristotle applies this kind of logic to politics. For example, countless other disciplines and fade homage to centuries over. Devising logical systems. This book to start gathering all pieces. Reading Euclid. Okay, this looks like it's just a philosophy book disguised for mathematical logic. I like that actually. I definitely would not mind reading something like that. Spivak calculus. What? Wait, what do you mean? This strengthens my thinking. This looks like calculus. Why would I want to read a book about math? Your interest lies in that field, or not similar geometry. Is learn the method. Develop a method for thinking and demonstrate flex instead of points and axioms, and to start based on guides to road digits and start playing with fairy tales. On the other hand, having a system or theory, okay, to it, instruct it. You can't. Maybe theorem is really trying to deceive you. What? I don't know. To me, this just sounds like. Let's look at the preview. I'm really confused. Feedback calculus. Let's see if there's like a preview of this, because this all this means just looks to me like just a calculus textbook. Yeah, this is a calculus textbook to me. Yeah, I'm not quite sure what he's trying to do here. I don't believe in it, but maybe I'll read it in the future, but I highly doubt I would want anything to do with it. Operating system design, the Sino approach. There's no voodoo, you get a complete system, all the basic parts that are building it up. Okay, I might read this just for the sake of the operating system stuff. And mostly, I imagine I could probably just find like the spark notes of this and take the basic principles. I don't know. I think Euclid's Elements is the only one that really speaks to me. And then maybe the scene approach. The rest is just like, why? Why would I read this? I'm actually kind of crazy. I don't get it. Why would I want to read a book about calculus? Like I know he says that. Oh yeah, this like you need to You need to just. It's like it's about the logic, but it's like all math is logic. So I don't understand. Or maybe that's the way I just learned things. So I'm actually kind of not I kind of don't get it myself. Let's see. Let's look at his project on GitHub. If he's using Lisp, then chances are he's been around for a very long time. So it might be worth actually taking what he said seriously. I don't know. I think the only one that makes sense to me is the Euclid's elements. You should 100% be determined by retaking an exam, and then that the last attempt should be the course grade. Okay. Essential claim that this would be more accurate than grades than a mixture of homework, quiz, and whatever. Hasn't had much contact with people who have actually taught classes. Systems with humans with them behave in a funny way. Yep. I don't mean to suggest that they're optimal with understanding how they came to be. Chesterton's fence is the principle that reforms should not be made unless reasoning behind the existing state of the affairs is understood. Yeah. Don't make reforms unless you understand what the fuck you're doing. That kind of makes sense. In a matter of reforming things, there is one plain and simple principle, a principle in which we'll probably call it a paradox. There exists, in such a case, a certain institution of law, let's say for the sake of simplicity, a fence or a gate erected across a road. The more modern type of reformer goes up to it and says, I don't see the use of this, let's clear it away. The most intelligent reformer will do, if you don't see the use of it, I certainly won't let you clear it away. Go away and think. Then come back, and when you see the use of it, I may allow you to destroy it. Yeah. This is the principle that just says, hey, just know if something exists, there's a reason why. And know if you're going to do something about it, make sure you understand why before you get rid of it. That's not a hard ask. In your brain, only Paul Graham uses Lisps. Honestly, I have never touched Lisp or read it. My understanding of Lisp goes as far as it's a very old programming language that no one uses anymore. So it's interesting. But yeah, I guess as a way to apply Chesterton's fence even to programming, if you see a piece of code and you can't understand why it's there, then don't remove it. And I think that people really take this overboard and just say, hey, yeah, I don't understand any of the code. I'm not going to touch any of it. And they don't even make an effort to try. That's the part that is kind of weirds me out. 400-point breadboard. What? Write the statement by hand. I have not used it. Understand. What? So many steps. Holy fuck. A sweet optimistic begins their career. Nice version of the assignments. Submit their solution. Most are fine, but some are an assault on reason, which every word of the assignment creatively misinterpreted. It never stated which temperature circuit to build or how to prove what explanation is necessary. Yes. Correct. And most of the reasons are amazingly gracious and drop the issue. Some really keep complaining, asking for regrades if they aren't accepted. Contact the principal, blah, blah, blah. Yes. Never seriously worries that they get in trouble, and in the end they're vindicated. But the whole thing is a huge headache, and not very much what the teacher accepted an extra light salary and spent life doing. Yeah. So next semester they add a bunch of clarification, but nature finds a way. That gets misinterpreted too, so the more details get added by the time the teacher retires. You have monstrosity that's universally despised, but almost impossible to complain about. Yeah. So it's like, the assignment would just be like, understand it, but then the step-by-step is fucking crazy. And he's saying, why does it need to be crazy? To protect, so that way I don't have to deal with people who do unreasonable shit. Which kind of makes sense. Oh, I tagged the wrong user? Oh yeah, fuck. Let me go ahead and fix that. Thanks, Tanot. Okay. I don't know if you're aware, but Hacker News is built upon Lisp, which is Arc. Yeah. Oh, that's kind of interesting, actually. I didn't actually know that Hacker News was built on Lisp. If you have any resources on like the brief history of Lisp or anything like that, I would love to read it. So if you put it in the chat, I'll definitely bring it up later or read it myself on my own time. Oh yeah, me too. An agonizing talent for getting grades like 89.95. I've gotten that. This is a pretty good joke. Set a boundary at 89.5. I outweighted them. I've been 848.3. Why no flexibility? Well, suppose you are my teacher and decide to be flexible. Word will get out. You didn't just round me up. You made 89.5 to be the boundary. Suppose you don't do rounding, but allow students to submit regrade requests after grades are posted. Enjoy regrading every single assignment from every student near a boundary, plus debating the exact amount of partial credit for every wrong answer. Was that really only worth 3/10 of a point or 4/10 of a point? Enough to impact my future? Probably. Maybe. If it's systemic enough, it can happen. The problem is that student performance is continuous. You are forced to discernize into a number. Injustice and inevitable. Yeah. When you boil it down to a number, you're going to get some pretty cheap shit. Most students don't cheat, but some do. Most follow the incentives and make little effort to stop cheating. But some teachers are principled and determined to police cheating anyway. Arcane methods sound truly ingenious. Huh. Okay, this is kind of interesting. I think this definitely has some implications for real life, but let's bring out my clients. 11 a.m. Yo, hello.
Hello.
Hey, what's up?
Good. How about you?
Hey, doing okay.
Right.
Hey, yeah. So catch me up on everything and what you got going.
Okay. So after our replay analysis on Tuesday, I spent a really good time like reading the Pavlov's essays, right? Just to understand how he breaks down the logic to see if that clicks in my mind. And I spent a little bit of time like over my past exercises, like the problems I did in the past, to see what was exactly the API solution and what was not, so I can redo them.
Okay.
And yeah, so I spent a lot of time on the Wednesday, like doing this analysis and just taking notes of things. What can I do better? And I mean, like analyzing based on the points you gave to me on Tuesday, and organizing what I have to do. And then I did the 5 essays you said to me to do, which I send you in the link.
Okay.
And you asked to me like 3 for me to record at least 3 videos and like from past problems. I managed to record only 2 because yesterday I had to pack my stuff to move, so I didn't practice yesterday.
Okay.
But yeah, the essays usually they take much more time because it's like it's much more time than speak, right? So that was basically this, and then I revised all that I did to see where it doesn't make sense, where it's nonsense.
Okay.
And that was basically this during this gap.
Okay. I did that. Okay. Okay. How'd you feel doing the essay? Did you feel like you're missing a lot of details? Did you feel like yeah, like how did you feel doing it? Let me ask you that.
I feel that my thought being more organized and not so not so random,
Okay.
because I really took note of like the way that Pablo solved the question. He really was able to go in detail and then go to like a more how to say more like explaining more direct, like a 5 years old, you know.
Yeah, exactly.
So yeah, and this is what I tried to do, like to really make the person who is reading understanding what I'm doing, but in a simple way.
Mm-hmm.
And I feel like, yeah, as I mentioned, sometimes when I was doing the problem, I was sometimes just how to say, not seeing the whole picture of the problem and like skipping some examples
Mm-hmm.
or some things that was on the on the question description.
Mm-hmm.
And like the way that Pablo said, and I tried to implement the same. It's like, let me go back. Let's see the characteristics. What can we improve from the naive approach?
Mm-hmm.
Basically, like redoing what we've talked in the past weeks, but with more emphasis in like, let me, yeah, just write this. That was basically what I felt. Yeah.
Yeah, you should be doing that. And
Mhm.
that's basically why I made you do it. It's so that way you
Mhm.
actually like you can do it full top on down and be as detailed as possible about it. Um,
Uh-huh.
and so yeah. I was like thinking it might be a little bit of pain, but it's gonna definitely help you in the long run.
Mhm.
Because it's gonna as the reason why is because once you start doing this, then you realize it's
Mhm.
basically what you need to is come out of your mouth, right? When you actually talk about it.
Can you do what with my mouth? I just don't understand this. Sorry.
Oh, so what I was saying is that basically all the stuff that you're talking about here, like
Uh-huh.
this naive approach and everything, you basically need to do this for the actual interview, and you're gonna need to talk like this.
Mhm.
So, like
Gotcha.
for instance, let's look at this problem that you did here. Reverse a single sublist. This problem is concerned with reversing a sublist with a list, um, and reversing the second to fourth nodes inclusive. Okay, yeah. So here you can see like 753 gets reversed between in this linked list.
Yeah.
Um, and so so now as I look at the examples, it's possible to check if we copy the chunk from the start node of reversal until the end of reversal in a new list, then invert in place order n. Okay, so you decide to just check if if it is possible to check if we copy the chunk from the start node of reversal until the end of reversal.
Yeah, of the reversal point. Yeah.
Okay, you got to be way more specific. And you notice how immediately I just got lost.
Yes. Yes.
Did you try looking over this after you've done it?
Yes, I tried.
Did this make sense? Did you catch this?
Mm, yeah, for me, start node of the reversal. Like of the reversal, I mean, of the reversal point. I was trying to be more specific, putting the word reversal, but it
It is
made me.
just say like the node at which you start the reversal. I mean, I actually no, I kind of said the same thing. Okay, I'll let this one slide, but it was a little bit confusing to me. But all right, because the explanation should be self-contained. Anyone who is new to the problem should be able to read this and instantly not have to do an eyebrow raise. That's kind of the point here. Then invert in place in order n. Okay, we will have the desired chunk inverted but disconnect from list. Okay, but I understand what your point is here. It's to just copy the second to fourth nodes, reverse it, and then glue it back in.
Yeah.
This can be achieved by iterating on the original list to make one node before. After that, we can take that new list that was inverted, then substitute. Okay, yeah, that's what I said. This can be achieved by iterating on the original list to make one node before the starting point of the invert. This can be achieved by iterating
Yeah.
on the original list to make one node before the starting point of the inversal point to the first node of the inverted list.
Yeah. I was trying to. I'll take the last node of the inverted portion and make this point to like that part. Yeah, was hard to me to explain. basically.
Then you should redo it until you can explain it very simply. Like, notice how I just said it. I said, hey, the way to solve this would be to find the first and last node that we want, comma, then copy the list, reverse that list, and then glue it back in its original place.
But how do you explain like glue back in the original place? That's what I was trying to explain. You know, in more detail.
It's the way I say it is it's when I say detail, it means that you want to be able to capture just enough that the user doesn't, that the person reading it just, or in this case the interviewer, doesn't like eyebrow raise like, what the heck are you talking about? You know, because it's like there's like what's it called, a just normal distribution to this, right? On the far left side is when you don't give enough details. On the far right side is when you give too much details, and basically you end up confusing the guy. You want to hit the middle where you just give just enough detail that they understand, and simple enough that it's very fast for them to understand. It's kind of an art to this, but notice that the way I do this is I make a lot of analogies. I try to avoid a lot of like what's it called? A lot of computer science talk. I usually try keeping it at a level that people can understand, even if they have no computer science background knowledge. And so
5 years old. Yeah.
So I explain like I'm 5. So I always do this. And so you notice like how I instantly was able to say what you were doing in a very simple way without like having these really long run-on sentences.
Yeah. What else? Because I saw that Pablo sometimes he go very in detail, like in the explanations. So that's what I was trying to do.
I see.
If we go back on my first, so maintain this simple, like our past exercise from the past week. I did exact this. I was trying to be, simple, and I did exact what you mentioned, like copy the chunk to invert in a new list, then glue back in the original list. I did exactly this.
Okay.
I can even show you.
I know you did that, but I'm trying to explain this point here. There's a very fine line. So it's like undershoot, overshoot. So now try to aim for the middle.
Okay.
Is the way in which you write, and then what you're writing about are two different things. Does that make sense?
Yes.
It's like it's like in this case, you want to be detailed, but you want it to be a simple explanation of the details as well.
Yeah.
And that's gonna be a very hard balancing act, especially because what's called, like, I understand that English is not like your first language, and I'm totally understanding of that. But at the same time, it's like for the interviewer, we want to hit these marks and make sure that we give the interviewer no reason to dismiss you. So
yeah,
the main inefficiency of this approach is the fact of allocating space. Is that we use extra space. That's you can pretty much summarize this as extra. We use extra space.
Yeah, as I was trying to explain again, why we are using extra space.
Is the fact that allocating space in in order. Okay, I see. Okay. Okay, this will be done in order of time, so we can reverse it and substitute on the original list. Okay. Better approach with given the fact of a new list being allocated. Maybe there's a way to do this without allocating new lists. Yep. Decrease time complexity. So now, how to do this in linear time by moving forward with an in-place reversal of the marked chunk. Normally, not to lose the references. Okay. So say we found a normal traversal on the path, acknowledging what index we are. Hence, once found the start of reversal, we need to perform this in-place reversal the delta times. I don't understand.
I define delta. It's like delta is the difference between the start point and the end point.
Okay.
Like the index, yeah.
Okay. So you're saying okay, I see. So you're basically saying the chunk that we're interested in between the first and the last points. Okay.
Yeah.
Is our chunk inverted? Okay, so then here, dummy node, you create a dummy node, and then you restart. So you're just iterating through and gain a previous node. Previous node, first node, delta does not equal 0. And so that's the in-place reverse. I think that's the in-place reversal.
Yeah, that portion is.
I see. So you're okay. So I see. So here, yeah, you iterate, and then in that it should be able to you do an in place reversal. So let's take let me double check that your code works. So then here you're gonna start. You keep maintain previous. Start -1. Okay, yeah, you count down the number of nodes you want to look at.
Mm-hmm.
And then here, so now then you get your node that you're looking at. Last equals previous. First node equals current. Okay. Do you ever use for okay? First node is current. And then while delta does not equal 0. Okay, count down delta itself. All right. And then reverse in place. I think this pretty much looks correct. Did you try this on any other examples?
I tried on this example, which is the same, I guess.
Did you try on any of the corner cases? Do you remember what we talked about last time?
Cover my ass of examples.
Yeah. Cover your ass. So, like, looking at this, what are the other things? What are the things that can go wrong?
Like with one node, I will try with one node.
Yeah. I mean, there's also like you might want to. I assume that the computation is gonna give you a valid inputs, but what happens if you don't have valid inputs? For what instance, what if the last node is out of bounds?
Yeah, I should like, I mean, like if the start and end of the reversal was out of bounds, yeah, I should be aware of this.
Yeah, or at least ask that question. Remember, where can I go die?
Yeah, I should put like to ask a question about this.
Yeah, so do what more examples? So it's like make sure you cover your ass.
Mm-hmm.
So it's the same thing I mentioned in the previous weeks. The same exact thing.
No, but yeah. Sometimes when I think about something, I need to write because. Anyways.
I mean, I don't really know what the excuse is here. I mean, we've mentioned it
you're right.
times.
You're right.
Like,
because I thought about it. Maybe if the range of the reversal is greater than the list. No, but I think yeah, I should like test.
Yeah, like I mentioned.
Bulletproof.
Yeah, I've mentioned this many times. So I have to mention it again. So. Okay, let's try it. Let's look at the next one. Take a look for a cycle. Take the head of the single list and return node. Does not exist as a cycle, and the node at the end of the cycle if a cycle is present.
That's a problem description. Yeah.
Okay. Given the fact that when a cycle exists means that the node point is pointing to a previous node, so if we store all the visited nodes in the list and iteration check if we've already visited nodes, with that we will know when some node we are traversing to, in case we just add the current. This is a very long run-on sentence, by the way. So I really need you to proofread your stuff.
I even translate to see if that makes sense in my own language.
Okay. But it's not about your own. I mean, unless are we doing the what's your native language? Like Portuguese or Spanish?
Portuguese.
I was like saying it's either Portuguese or Spanish. I'm pretty sure it's Portuguese. So
yeah, it's Portuguese. Down here, South America, only Brazil speaks Portuguese. Anyways.
Gotcha. But yeah, like keep in mind the interviewer I don't know if the interviewer is actually going to speak Portuguese or English.
Yeah, for sure. You're right. No, I was just translating to Portuguese just to see. Okay, there's no excuses. It should be understandable by a 5 years old Brazilian kid.
Mm-hmm.
So that's what I was trying to do.
I see.
To see as clear as possible.
Okay. Try thinking of like a 5-year-old like kid who doesn't speak Portuguese. So I was like 70% certain it was Portuguese. I'm like, oh, it could have been something else, but yeah. Either way, Um, my point here
Yeah.
is that this is kind of very long and run on. And I get I don't and Pavel is also like I think German, yeah. So his English is not his native language either. So I mean, he definitely has a way of writing that is very detailed as well. So I'd rather you be over detailed than under detailed, but this is just something I'd rather keep in mind, especially when you start talking about these things. When it starts translating to the actual world, actual interview, you might need to talk a little bit more simply, like the way I'm doing right now, and that is practice. It's hard for me. Again, it's hard for me to really give you a formula. I can give you an argument, but I can't give you an understanding. If that kind of makes sense. So I'm just making you aware. Hey, this is like kind of a run-on sentence. You might want to be aware of this. Okay.
Okay. Yeah, I think this boils down the same idea. For the past one, I did pretty simple, and sometimes I skip details, you know. So, and
Yeah,
now I did too much detail that complicated the explanation.
I think your details is fine. It's just that the explanation is too long. But the level of detail is fine. It's just being able to synthesize all this into a very easily understood sentence. And that's a grammar thing. Believe it or not, that's not even like a lot of things I'm talking about. It doesn't even do with coding, right? It's about just interviewing and talking to people. And you know
Sure.
that's also an element to the interview that I think people also somewhat neglect. But it is going to be relevant because if the person cannot understand what you're talking about, they're not going to be able to follow your thinking. Either way,
Right.
I'd rather you be overly detailed right now than under. But we're gonna try like over right now with practice. We're gonna try reducing it. So this operation to verify the existence of a node in every node will take order n squared time because at each time we are iterating over all the nodes visited. Yes. The operation of revisiting all the nodes in the past takes
Okay.
too much time. Order n squared. That boils down the question: can we do it faster? Instead of using another list to verify each past node's existence that takes order n squared, we can use a set. For each node that we visit in the list, we will check if we already are in set, and if so, we output the current node at the start of the cycle. Otherwise, we store the current node in the set and keep traversing the list. Instead of using another list, we use a set. So how's that different? So for each node we use in the
Because
set.
the lookup time will decrease. So from all of n, yeah, we can check lookup in a set.
You
all
want
of
to be
one
very
time.
specific of that. If you want to do like an order, what's it called?
I put in the end. Actually.
Okay. It needs to be a hash set, by the way, not just a set. A
Oh,
set can be anything.
okay.
Here's the thing: you need to do a hash set because you're basically describing taking advantage of the hashing algorithm.
All right.
Because there's many different the thing is that there's many different types of sets. So
Could be a set of anything. Yeah.
correct. Like the set could be unordered. So yeah. Like what saved you is that you were able to say order one. It's like, oh, okay, you're talking about a hash set. So that's where details can save you. But yeah, it's better to just like not have to rely on that. So, so we're using extra nodes, optimal solution, Floyd cycle find algorithm, basically guarantees that we traverse this. Okay, fast slow pointer. Yep. Okay.
I have one question about this. For example, I saw that in EPI solution, they only say a fast and slow pointer, right?
Uh-huh.
But there's a very complicated explanation for this Floyd algorithm.
Okay.
I am assuming, and then I tested that this worked. You know, once I found that the pointers meet, I need to like start one pointer from the start again and increment one by one, and I will find the start of the cycle. That's the algorithm. Do you recommend like to be very? I mean, I knew how to explain this algorithm when I say the name, or it's better for me. Okay, let's use slow and faster pointers, and that's it. As
That's a good
you
question.
mentioned, like colon EPI solution. EPI didn't just said slow and fast pointer. Anyways,
Okay, I understand what you're saying. That's actually kind of that's an interesting point. Like, do we want to describe Floyd's cycle find algorithm, or do we want to explain it first? I really just like. I personally am not in these interviews. You're most likely not gonna have to pull out some fancy algorithm out your ass. You're most likely just gonna be able to just simply describe it. So I would say
okay.
just name it first, and if the interviewer goes, "Huh, I don't know what that is," just simply do the simple explanation afterwards.
I was aware. Maybe I should to include the explanation about this. On
It's
the
just
following
it should be a
sequence.
small like 1 sentence explanation. It's like, but yeah, I understand this. This is completely fine. I already understood what you're talking about here. But the thing is
Uh-huh.
that are you still slow equals? It's like okay, but you're. It says you need to find the head of a single return is null if there doesn't exist. But you're the node at the start of the cycle.
Yeah, the node of the start of the cycle.
How does your code find the node at the start of the cycle?
So I find where the pointers meet.
Okay.
But as you mentioned, it's not guaranteed that this is the start of the cycle, neither the end.
Okay.
So we need to, again, take one of the pointers, put on the start, and then advance one by one. And when they meet again, it's guaranteed that that's the start of the cycle.
Wait. Given the single element, this may be not desirable from. Okay, for all the lists down below overlap at node 1. Write a program. What? Where are you going
No,
with this?
that's the other question. That's the other question, actually. You're in the other question.
Okay. So then, in other words, is this from last time? Because, it's like, yeah, you didn't put the code in that said, oh yeah, find the head. So I don't know. I would have done that.
No, that is the code, actually.
That is a code. So okay. So you found if slow equals fat. Okay, so you find this, and then
Yeah.
slow equals head dot next. Oh, okay.
Yes, and then we move one by one. That's the point. Until they're different. Yeah.
So slow equals head dot next, while slow doesn't equal the fast pointer.
Yeah, so in this part here, I am like resetting one of the nodes, to be at the start, at the first node, and then I'm iterating one by one. So when they meet again, it's guaranteed that it's the start of the cycle. Basically, that's it.
I don't see it. Because did you try testing it with? Here, let me just bring this example again. So you're saying let's say they find it at let's say they meet at 4, right?
But actually, they need to meet in the right place. It's not like random. So we need to see where they meet.
Okay, so if you tested on this example, you should be able to tell me where they meet.
Hold it. Test. I should like. Okay, I tested here on the.
Where did you
I
test?
tested in past examples actually. Or I should like include again the test here
Yeah.
for you to see.
Okay.
So imagine that we have 2 pointers,
Okay.
right? X and O. So for first one, X is the one that's gonna walk 2 by 2. Then X is going to be on node 3, and then O is gonna be in node 2. Then X is going to be in the node 5. Then O is going to be in node 3. And now X is going to be 1 and 3 again. And 3. So they meet. Right? So since they meet, now we take one of the pointers. In this case, we took the slow pointer, right?
Okay.
And go back to the head. And hold up.
Now I see. So now your slow is at the head, and then now while slow does not equal fast, slow equals slow down next, fast equals fast down next.
Yeah, hold up. That's the minute.
Okay, so then.
Yeah, we advance 1 here, and then another here.
Okay.
Then 1 here, then another here.
Okay.
And now here's the start of the cycle, actually. Actually, here's the end of the cycle. And
Okay.
then we advance 1 more. This is like...
But your loop is slow does not equal fast.
Still is not the same. We are iterating, and they are not the same still.
Yeah, they'll never be the same.
No, but at some point they're gonna meet, so let's see.
Okay, what? Play it out for me. Play it out for me.
Okay, now one by one.
Okay.
Uh,
Show me where they meet.
oh, yeah, I understand. And yes, I played with you. I showed you, and it's that should test this to make sure that it works.
Mm-hmm.
I understand the algorithm, but I implemented this wrong. That's the point here.
Yeah, you should be testing it.
I tested, but it's gonna be in a.
If you test it, then why is the test failing right now on a very simple example? We didn't even go to like, oh, what are the other ways that this could fail? Like, what if I add like a 0 in front, or like a 10 in front or something like that?
But the algorithm is general. It should work for all the cases,
Yeah,
where
it should.
List have a cycle.
It should, but you need to test that. Like back up there, right? The same thing I said before. Like, cover your ass.
The
Where
same
you blow it
thing
up?
you said before, yeah.
Yeah, try it on a bunch of different examples, and you should be able to do that. You should be testing it on a few examples beforehand just to make sure that it works. But yeah, so it's the exact same thing.
What I feel is that sometimes when I focus on something, but as you mentioned, I need to compound all the habits because it needs to be a complete package, not like pieces. Yeah.
Okay. So then, do you need like? All right.
No, you don't even need to read to actually.
Do I need to copy paste it again and write it out, or?
No. It's here. I know what I have to do.
Okay. You need to keep a list, man. Like every single mistake that you make. A mistake at this step. This is the mistake I make. This is like how to avoid it. So keep track. Write that list. Because otherwise I have to write that list for you, and at that point I'm just like, I'm basically handing you a recipe.
For sure. Yeah.
You need to be more responsible for your own learning, because obviously this is not what you're doing is not working.
No, you're doing. I mean, there's nothing more you can do. That's my fault. I totally acknowledge this because when I focus on something, I don't do other parts. So I need to checklist until it's second nature to me, and I don't need to think before doing.
Yeah, and then eventually when you make a list, you do it over and over again. It'll be discipline creates good habits, and you won't have this problem again. Because at this point,
because some things I can do this like the way you said, but I feel at some points, this part of the test, I forget again. Not that I forget. I didn't do it. Yeah.
Okay.
Which can kill me.
Yeah, it's gonna kill you, and it has killed you twice already. So it's like, to me, the very obvious thing is that your practice sucks. No other way to put it. Your practice sucks. That's why we're not making progress. And I'm giving you all these different exercises, and I'm saying, hey, keep in mind all these different past points, but we're not getting anywhere because your practice still sucks. You're making the same mistakes.
I feel, as I mentioned, I focus on something and don't do other part. When I'm good on the other, it needs to be second nature. All the things, all the habits.
Yeah, and you say you focus on one thing. Well, make sure that one thing you never forget it, because it seems very obvious to me that you're forgetting it.
But I'm forgetting the past ones. That is the point.
Yeah. So make sure you develop good habits. Right now, it's all about making sure you develop those good habits. So you know what? For today, let's see. I want you to write that list right now in front of me. Write that list of every single mistake that you're prone to, the step-by-steps,
all right,
and what you need to do.
What up?
Because at this point, there's no point in doing problems right now if you can't get this down right.
You're right. Right. Okay. So, you mean like when I'm solving a question, right?
Yeah.
Okay. So the first one, walk.
Where are you putting? Wait. Where do you?
Actually, read the problem 3 times. That's what I've been doing.
Wait, I literally have this all highlighted. Come on. Wait, what? Yeah, what are the common mistakes? I'm looking at
that's the things. Can you just repeat, please?
Look at the prep doc. I highlighted it 3 times, make you understand it. Tweak the problem. Did you have complete test coverage? Did you cover your ass in all situations? Make you test.
Yeah, you highlighted.
Yeah, I highlighted all of them.
And you put like tweak. Actually tweak. the example. The example where it breaks.
Where are you writing
Actually,
this?
to cover. No, actually, the examples to cover as examples. Okay, and test the corner cases and test the corner
So
cases.
it says cover your ass.
Yeah.
Cover your ass.
Okay. After doing this, I can go for like the naive approach. Try to actually walk through. Walk. Now is the part of walk through the examples to derive a naive approach. And then, write the naive approach. Actually, write and then actually test before write. And then write the naive approach, right? Acknowledge the inefficiencies. Acknowledge inefficiencies. And, try to acknowledge the inefficiencies and create a new hypothesis for how to solve the problem, like or decreasing the space or decreasing the time. So create a better approach. Test it again before anything. Test it. Like with the same examples that I covered my ass. And then if I still not sure, do a pseudocode. Pseudocode, test it again. And finally, do the code and test it.
Yeah, that's if you want to be giga detailed, but obviously, like, there's some things that you're not gonna do during the actual interview, like the pseudocode or whatever. But it's really important that you cover your ass. Seriously, like, what is everything that can go wrong? And this is like the really important part where you actually need to you need to hammer this point home, because you only get a sense of this once you actually really evaluate your mistakes. Like, this is what we call experience, right? So it's like, oh, I made this mistake before. How do I prevent myself from making this mistake again, or missing this corner case and all that stuff? So this is where you really need to be giga detailed. I even wrote in your doc last time, like, hey, don't be very lackadaisical about self-evaluation. You need to be more strict. Like, you need to be really, really strict about yourself. And
can I just say a problem
Yeah.
so you can understand what sometimes I feel I am having while practicing. So for example, like from the past weeks, I've been like following this framework. Actually, this one I was not doing because we didn't talk about this.
Okay,
yet.
put that back in. I'll just strike it out for now. Yeah.
Yeah, from the past, I guess, to the past week.
Yeah,
actually.
put it back in for now. I'll just ignore it, because I want to keep this out. Can you put it back in?
Yeah. Oh yeah. How to go back?
Okay. Yeah, that's fine. I get it.
Yeah, and but sometimes I feel like, okay, and you said to me, okay, now let's do the essays. Let's do 5 of them, right? And then okay, but now you should focus on explain like I'm 5, and you see how to go in details and not.
Right.
And I focus on this, and I forget, like, for example, the task part, that I've been doing in the past, all the past weeks, and to just hammer, as you mentioned, like to this part, really solidify my mind. Okay. And because while you're reading the problem 3 times and walk through the examples, the right approach, and here is where I have to,
Okay, I see where the problem is. You're trying to memorize the step-by-step like a recipe. You're trying to memorize each step. Oh, step 1, I need to do this. Step 2, I need to do this. Step 3. What I'm trying to get you to do is get an intuition. It's that this whole cycle of naive approach and optimizing over and over again, that should be like one thing in your mind, right? And then the other times, should be, hey, I need to make sure I test every step of the way. But over time, you should be more confident with it, right? Like you should say, oh, it's very obvious that this is gonna work. I don't need to like really test it that much. Sometimes you'll be like, oh, I'm not 100% confident that this works, so I need to test every other possible angle. But mentally, you should already be doing this. Like, what are all the different ways I can go wrong? What are all the different ways I can get blown up? And this doesn't change. Like, notice like how often I say test it, right?
Mm-hmm.
This applies when you are not sure about it. If you're 100% certain in your approach, fine. You gotta then go right on ahead. You can skip the pseudocode. You can skip the test. But to me, it's like you are getting blown up. You just get, and then you realize, oh, well, I need to do this next time. And then just kind of like go on as if you didn't like get blown up. So that's why like this isn't working. It's like you're not learning from your past mistakes. It's like, hey, maybe at this point, I need to realize I need to test it. You know, at the end of the algorithm, or the end of the code, I need to test more than just the examples, etc., etc. So you should be like, these past mistakes should be teaching you, hey, maybe I should test this more. Or maybe this is like in a linked list. These are all the different ways that I get blown up. Or, oh yeah, like for what, like for instance, this test for cyclicity. It's like you are relying on the points meeting somewhere, and then you're relying on the, what's called, this assignment to the head of the list, right? So to me, that's already saying, hey, well, what can they be assigned anywhere in this list? So as long as I can do it in general, then I'll be fine. As long as the number of elements ahead of the cycle list should be variable. Like you see, like the moment like I see the way like what your code is contingent on, I'm thinking of ways how to break it, and you should be doing that to yourself as well. So the one you keep like literally there's like so many points that you say test it, but those are points that you should be able to test. And those are points that you should be immediately thinking, hey, I've said this, what can go wrong? I've said this, what can go wrong? You should always be thinking about, like, what can go wrong each time. And then how to get better at detecting this ahead of time. Like, this is what we call prediction, right? It's like having the experience and learning from that experience. And right now, you haven't learned from the experience. That's the problem we're facing right now.
Yeah, because I have all of the points, right?
You have every single tool.
I'm missing.
Yeah.
Yeah, I keep repeating the same errors over and over.
Mm-hmm.
Yeah.
Yeah.
Because anyways, I record the videos. I think it's more real.
I don't need to see the video right now. I need you to do like these examples and cover your ass and really test every single point. Because it's like if you don't test it, you just kind of like write the code, go on, done, whatever, and you don't think about how to make it more efficient next time. In fact, did you even compare this to EPI?
I compare.
So then this should have immediately come out to you like, oh, well, why didn't this work? Or why is this different? If it's different, then you should test it to make sure that you really do get the same answer. Because right now, to me, this is like, there's no way the book would ever do this. Like, they might get the similar structure, but they wouldn't get the details of what kill you. And this detail killed you.
Yeah.
So it goes back to the same thing. You're being like, oh, they gotta get the similar same thing. Whatever, I move on with my life. That's not the way it works. You need to be really critical.
I'm trying to be the same as the API solution.
Was this the same?
No, because they found the start of the cycle different than me.
So why didn't you go back and fix this, or at least try writing an essay like, oh yeah, this is what I got. This is why I'm right. This is why I'm wrong. If the book gets something different, why does your solution align? You know, because you could write something like iteratively versus figuratively, and what are the merits to their solution and yours? Why? But in this case, I would literally just say, just assume that the book is completely 100% right. You need to get basically really close to them. So.
Mm-hmm.
Yes. So at this point, there's nothing I can do for you other than to just say, hey, you need to basically keep practicing the right way. But if you're not able to do that, then I honestly see no point in coaching. Because I give you all the tools. You have all the lists. You have everything here.
Totally. Yeah.
So it's like if you still don't get it after this, then there's nothing I can do for you. It's a matter of how disciplined you are in practice.
Yeah. I think in terms of like allocate the space and time to practice, that's not a problem for me. I feel like sometimes, I, yeah, sometimes while practicing, I need to be more in like.
You need to review you need to review your answers. You need to review what you do and be very critical. And that's the part I've like been saying for like 3 weeks now. Is like you need to be very critical. And what I mean critical is like every single detail. You need to make sure it lines up. And that includes the code. That includes your the approach is fine. It's the code and the testing that's killing you right now. It's like, hey, well, how do I know my idea is correct? So at this point, there's like, even if I do another problem, we're just gonna run into the exact same issue.
Can you just review one more problem, please?
Okay. I can review the problem, but I'm pretty sure we're gonna run into the exact same thing. So let's look at
RPN expressions.
Didn't we do that last time?
Yeah, but just to see. Yeah. Anyways. Okay.
Okay, let's take a look. Okay, so yeah, no examples. Yeah. Okay, fine. So let me ask you, what was the point of these examples? Every example, it can't just be random examples. It has to be like
no.
There's be
not random.
These all random?
No, I was trying to extrapolate. I mean, to try to see this property of ERPN, how this can be applied in different ways. That the examples that was given to me did not show me. So I was trying to make them like as you did in the last time, that you break my code, just trying another type of expression. So that's what I was trying to do.
Okay.
Here.
The thing is that the way I broke your code wasn't literally from random examples. The way I broke your code was just literally understanding what the problem was asking, understanding what you did, and your understanding, and just say, hey, this is the delta. Here's an example of that delta. So examples really. So when you come up with these examples and you want to bulletproof it, you need to understand the principles that are guiding the problem. In this case, that formula A, B, and then operation, and then to me, that instantly screams recursion. So it's like being able to come up with that recursive formula. So to me, these examples look random. It's like I'd rather you do that. To be honest, I'd rather you come up with a shit ton of random examples at this point. Before we go to like the guided examples, because at this point, then you're gonna start thinking, hey, wait a minute, how do I really need all these examples? Did they advance my understanding anymore, or were they just like random shots in the dark? Was there a objective to them? Were they all trying to cover the problem?
Yeah, I was trying to do the second option, but
okay. But you need to understand why you're doing the examples and what purpose they serve.
I was trying to go to cases that the examples on the book didn't cover.
Okay. I get it.
So if you go in the last example, basically the last example is like two expressions, and then I have to divide them. So that's a great example. That's what I was trying to do, to see if I can create an approach that will solve like even those corner cases.
Okay. Okay, fine. I'd rather you do this than anything else. I'd rather you like test it out like on outside examples. Like if you did this here and then you just kind of drop the ball on the other two problems. So.
Oh, you're saying now that new examples are not good?
No. I'm saying that new examples are good. I'm saying that later on you're gonna find that that a lot of these new examples that you're doing just are somewhat meaningless. But right now I'm saying I'd rather you do this, because it's like everything comes with nuance, everything comes with detail. I'm saying right now just focus on just covering your ass. I'd rather you focus on that and just do a shit ton of examples than to not do any examples at all. So this is fine for now. I'd rather you do this than not have examples.
Yeah, I got you. Is there anything else? I don't know. I'm gonna like listen to practice.
Yeah. All right.
Oh, actually, I reviewed the videos that I recorded and compare with the past ones.
Okay.
I feel like it was more clear what I explained on the videos. yeah. Anyways, and I solved the question
Fine. Okay.
in less time.
Okay. Let me think. Let me think. What? Give me a sec.
Mhm.
Yeah, at this point, there's no point in doing like more problems until you master this approach completely. So what I want to do, I'm going to do. So let's do this. I want from now on, if you cannot, do not submit something to me unless you've walked through the steps. If I'm literally going to the next time I see you, I'm going to run through this. I am literally going to say, did you read the problem 3 times? Did you do this? Did you test your example? And if something is very obviously wrong, like I'm going to say that's it because at this point, like it's like been 3 weeks. We've been talking about the same shit. Like at this point, I don't know if you are taking this seriously, or you're fucking with me, or what. So so I want to see you for homework. Just keep making progress to the problems or redo old problems. At this point, even doing the old recursion problems are gonna be fine. But every single problem that you submit needs to be done with this. Needs to pass this test. And I'm gonna increase the stakes. If the next time I see you, there's a problem that doesn't cover this, I'm gonna drop you. Okay?
Okay, fine.
I really need you to do this. Like, I'm not fucking around, man. Like, it's the same
Man,
problem in 3 weeks. It's like, at this point, you really have no excuse.
Okay.
So.
I just have to say that I'm not like I'm pretty serious of this, and is the problem that I mentioned.
Then if
You
you're
give me
serious
new
about it, why are you
problems to
making the
work.
same mistakes? Why it's the same thing. And I've even highlighted it for you. Like, they cover your ass in all situations. Remember, I've said this like a few weeks ago. Like, if I've highlighted for you, I should not have to like repeat myself more than like once or twice. But I feel like we've already done this like 3 times.
There's no more point in coaching, actually. Right?
Yeah. So it's like either you get this through your head and you do it, or we're done. I'm gonna give you 1 week. So it's from 319. As I get it, you might miss some points on Tuesday, but by Saturday I see the work and it's still not improved. We're done.
Okay.
Yeah, there's no, and besides, like, you have your interview at 3:30 on the end of the month. You need to basically you still need to do dynamic programming. That's the problem too.
Okay. Anyways, yeah, I have all in hand now. Right.
Okay, you have everything you need.
Okay.
At this point, I'm gonna let you go because there's no point in doing a problem with you. And you still need to do dynamic programming. Like, holy shit, we're like a month out. Oh, gross. All right. Well, yeah, there's no point in like progressing forward until you can do this. So, I'm gonna let you go, but you understand the stakes now.
Mm-hmm.
All right. Any other questions?
No.
Okay. Then I suggest you practice for the rest of the evening or whatever time, and then make sure and then be prepared. I'll see you Tuesday.
Okay. One thing. Actually, Facebook interview will be Wednesday.
Okay.
So. No. Anyways. Okay. No, I was just gonna focus on what we're talking about.
Yeah.
Because if I master this, it's gonna be a good interview actually.
Yeah, because there's not enough time to do dynamic programming. I'd rather you like mess up one dynamic program problem, and just be like, but you ace everything else, than to be like, oh yeah, well we're studying for dynamic programming that doesn't exist. Like, so it's you have to move to Facebook on site or phone screen.
They said it's phone screen.
Yeah, that's what I figured. Yeah, you basically need they're not gonna ask you dynamic programming. I'm pretty sure. But right now, you're nowhere even near the phone screen level stuff, because this example thing is killing you.
Mm-hmm.
So, I mean, I'm gonna cross my fingers for that.
Last time was a question about create a simple calculator with plus times and division, right? So that was the question. Anyways.
Okay.
I did this in 2 passes, but anyways, yeah, just to let you know. But okay, man, I think that's it.
All right, that's it. All right. All right, see you later.
Okay, bye.
Bye. Jesus Christ. Yeah. So let's see. Nice comment. Think I'll drop him. Like I don't know, man. Like it's like how do I get through it? Like I'm saying, like you have to take it seriously. Take it seriously. Take it seriously. But I don't think he understands how serious it is seriously. I mean, literally drive yourself fucking crazy trying to compare yourself to the book. Like literally, every little detail needs to be scrutinized, and it's just like I'm trying to convey that to him, but it's very obvious. Like I just do a very simple smoke test. Hey, does this code actually work? You know, I just throw one example at him, and it's just like, or just you throw the book example at him. So it's like I can give you an argument, but I can't give you an understanding. So it's like sometimes it doesn't work, you know. Like as I tell someone what to do, I highlight it for them. I list out very much. I list it out, and if they can't do it, like I try adding like, okay, let's focus in on this. Let's focus in on this. And at this point, I'm at the point of like, okay, well, I've given you everything. I've given you like every single pointer, and all that's left is how hard you are on yourself and how well you do in practice. Like doing additional problem is not gonna help. Like there's no point in keep doing like coaching problems and live interview practices if you can't even do this. So we'll see. Anyway, I guess I'll stop the stream because I don't have anything else left, unless anyone else has any questions. Yeah. So if anyone has any other questions, I guess we'll stop the stream for today. We'll have stream on Tuesday, 8 p.m. Pacific Standard Time. Y'all know the drill. Thank you all for joining me. And hope you guys learned something, and I'll see you next time.